So hi, I'm Thomas. I'm from an organization called Akvo. We're a non-profit foundation. Everything we do is open source. We do data systems and we do sensors. We've just started doing sensors. And I need a presentation. It's a power poop thing. That was quite there. That one. Thank you. So I'll stand over here. Maybe we can see it as well. What did I press? It went black.
You probably pressed the in button. I've done that many times. You
Yeah, I must have done.
Like
Sideways. So, sorry about that. Sideways. There we go. So we build open source hardware and software. It's mainly used in international development, and so lots of stuff in Africa, South Asia, Pacific, Central America and stuff. And we're a bunch of us. We started 10 years ago. We're about 75 people now, and we're spread out sort of all over the world. I'm in Stockholm, obviously. And I want to talk about something called Akvo Caddisfly, which is essentially a mobile laboratory for water testing. And the people that have invented this thing, they're a bunch of hackers from Bangalore that are now on our team. They're really awesome people. And now I pressed that damn thing again. It's like, so here is some of the first prototypes. So what are they prototypes of? They're water quality tests. So there, in a lot of parts of the world, there's water that you drink that is not safe to drink. And often people take it out of a well and they have nothing else, or from a groundwater source somewhere. And fluoride, in this case, is something you have in your toothpaste at small levels. But when you have lots of it, you know, your skeleton starts bending and doing awful shit, essentially. And it's not repairable once it's started, right? You can't bend the skeleton back again. There are other things that we're also working with, but fluoride was where we started. And the guys, they built a bunch of different types of prototypes, and this was supposed to be connected via DSM, and it was going to send things to data system somewhere. And it sort of got too complicated. So we decided to do it as a mobile phone attachment instead. So this is an early prototype of that, where you take, the way it works is you take a bit of water, you put it in this container, you add a reagent through a little capsule, you close the lid, it injects it, it colors the water, and then you read the color with a camera, and you get a result. And it's pretty cool, because we just published a paper that essentially, scientifically shows this stuff is as good as the expensive lab test you can get, but you get it in a minute. And this is pretty awesome, actually. So, but it turned out prototyping. When we were doing this stuff, we had some trouble. We could get this stuff to work. This is a later version, works really well. It's being used now a bunch in different pilots to show that so we could do that paper and say, hey guys, this stuff works. But calibration, all the cameras on all the bloody phones are different. It's a bit of a problem. Even phones of the same make, brand, version, etc., everything are all different. So we had to fix that. The phone sizes didn't work so well for that combination either. So we ended up with a hybrid solution with an external camera that we're working on right now. But he also learned that, we could read colors just with a camera. So we're doing something called, you take a test strip, you do the pH test, stick it in and says, oh, it's like 7 pH, that's good, I can drink that. So you can do that with lots of things for iron, nitrates, lots of other things. So we've made software now that you can take a photograph of a strip test, and actually it does the job better than the human does it. We've just proven that as well. So that's pretty cool. And we're just testing this right now. In Mali, they're doing 8,000 tests for real, and all of this stuff uploads to the cloud service, so they get all of this, near real time. And this stuff is going to make a huge difference for a lot of people. And if you're interested in hearing more about it, I'm around.